Hello there! I like birds quite a bit, so I built this frame that displays all those that are outside my apartment. And you can as well. Let's get into it. These are all the parts you need to build a bird mic of your own. You can find this bill of materials on my site, theodore.net, or in the description below. And you can also buy a kit from me at theodore.net/store. And it comes with this little Raspberry Pi 4B, a tiny USB lav mic, USB power brick and cable, as well as an SD card. The project is based on the BirdNet Pi repo, which comes out of the wonderful Cornell Ornithology Lab. And the SD card is where we're going to start. So we'll hop into an instance of Raspberry Pi Imager and select our device, the Raspberry Pi 4. Then we'll scroll down in the Operating System tab to Other and select Raspberry Pi OS Lite, the 64-bit version. We'll select our mounted SD card as our storage device, and then move on to customizing our hostname. I'll be using BirdNet. Then we'll move on to localization. It's just your time zone. Then you can set a username and password. The default is Pi and Raspberry, and that's what I'll be using for this tutorial. Then you'll set up your home Wi-Fi network. I've already preloaded my SSID and password here, but you'll type in your own credentials. And then we want to make sure that SSH auth is toggled on. Move on to Raspberry Pi Connect, which we don't need. And then we'll proceed with writing the image. You'll see this little pop-up, click I understand, and our write's complete. So we'll finish, eject our SD card, and hop back over. Awesome. So now that we have this flash, we'll go ahead and load it into the back of the Pi, just in this little slot in the back. Then we'll get our lav mic plugged in via USB. And we'll get this thing powered up. Once this is powered, we'll SSH in and get the BirdMic software installed. Okay, so starting in a new terminal, we'll SSH into our Pi with our username and hostname that we previously set. Then paste in the installer script that can be found on the project documentation. The installer can take between 20 and 40 minutes, depending on your Pi and the Wi-Fi network you're on. So grab a coffee, hang out, look at the birds. And as the installer wraps up, it should reboot itself. You'll lose SSH connection. But then we can open a new browser window and access our BirdMic with our hostname.local. Now you have access to the collage, the stats, the atlas page, and you'll be able to change things in your personal menu. Switch into dark mode. You can change things like the confidence threshold of the bioacoustics model. Anything you need to dial in your setup. With that installed, we'll move on to the pieces that we set aside earlier. If you ordered a BirdMic kit from me, it will come with these two printed parts, as well as 3 stickies. And in addition, as an added accessory, you can also get this mic mount, which comes with 2 stickies. And all of these files can be downloaded and printed for yourselves. We'll start with the case itself, so we'll get this mic mount set aside. It's quite easy. You just drop the Pi straight in. And then this cable, when it's in the middle USB slot here, or frankly the left slot as well, but the middle one gives you a bit more room, can just be finagled out of the right and set atop this little pyre here. We'll set the cable like that, then we'll proceed with putting the top of the case over top to sandwich the cable nicely in place. And then we'll just apply a bit of force to snap this whole thing together. Now it's secure. It's nice, aesthetic, keeps the dust off the parts. It's designed with California weather in mind. These are 2 wall layer prints, so I think it's really good for blue skies, but otherwise I would recommend keeping it out of the elements, and maybe at some point I'll do an all-weather case. Fortunately, you happen to have 20 feet of microphone cable with this little lav mic, so you can really put this thing anywhere, run the microphone to your window, or wherever you please. And then we have this little microphone case. You'll have to take off the muffler to install the microphone, but you simply insert it in the hole in the back. We'll pull the cable through, and then reinstall this muffler windbreaker. And then the microphone simply clips into place here. You want to be somewhat careful while installing this part, given these are FDM printed parts. So unless you're doing this with SLA yourself or at a different angle, you'll want to be somewhat careful. But there you have it. The microphone is now installed in the mic mount. This just gives it a bit more coverage in case you wanted to put it out on your balcony. And now we'll move on to these stickies. We can use two of them, this little 3M kind of command strip-esque removable stickies, to hold the cable in the back of the mic mount here, and also mount it to the wall. So we'll simply route the microphone cable down this little channel here, and then put on a 3M sticky over top. We'll do this again with the second one, to make sure that the cable stays in the channel running all the way down. You can be a bit more careful with your sticker placement than I. And boom, we'll stick this up on our wall and route the cable down. We'll do the same with the bird mic here. And there you have it. This is the bird mic built. To build a display of your own, here are all the components you'll need. We'll set aside the frame and backing for now, and just focus on these electronics in front of us. So, this project uses Spectra 6 e-ink panels. These things are just wonderful. They have a bunch of these tiny little charged ink particles, red, yellow, blue, and white, and they move through this fluid upward towards the view plane to show a picture, and downward away to show blank space. A really fun and lovely process to show our birds. Then to power this e-ink, we have this little Raspberry Pi 02W, as well as this little SD card, which we'll go ahead and get flashed. We'll hop back in Raspberry Pi Imager, and this time we'll select our Pi device as the 02W, and flash it just as we did earlier. We'll hop back and install our freshly flashed SD card within the Pi. You'll notice on the Pi Zero there are a few different ports. Micro HDMI, which we won't be using for this build, and then two different micro USB ports, the bottom of which is for data, and the top one for power. We want to plug our power cable into the top port there, and then we'll get this plugged into the wall and powered on. From here we'll hop back into a fresh terminal, SSH in, and get everything we need installed. This 02W flavor of Raspberry Pi OS Lite doesn't come with Git, which is a bit funky. So we'll proceed with installing this. And with this installed, we'll proceed with cloning our repo. CD into the repo itself, then the frame subfolder. Then we have a few different variants of the installer we can choose. By default, running install.sh will pair your screen with your own local bird mic. But if you don't have a bird mic on your network, you can pass in the bird weather flag and your own zip code, allowing the frame to be entirely standalone. Or you could point the frame at a public image URL and pass in a frame key if you want a bit of a secure parameter. We'll proceed with the default install.sh, since I do have a bird mic of my own up and running, and we'll just let the installer run. Now, a quick word on the illustrations we're using for birds. The repo ships with a bundle of species from Western North America. If your mic is outside this region, you may need to generate birds of your own. Doing so is somewhat intense computationally, so I've opted to do so on my local machine here. We'll create a Python environment, and then install everything we need. We'll generate the illustrations, passing in the zip code that the frame is located in. I'll use New York as an example here. This should prompt you for a paid Gemini key. It'll compare birds that are common to your zip code with those currently shipped in the repo, and generate any that are missing, and then cut out their backgrounds so they dither properly on the display. Once generation completes, these new birds will be automatically added to the repo's illustration folder, which we can open by copying the above path. And now you can see all of the illustrations that the repo ships with, plus the ones we just generated. And if we want to check out one of these in particular, we can CD into the illustrations folder and then open a particular bird file. And there we have it. To sync our new illustrations with the frame itself, we'll CD back into the root of the repo on our local machine and type out this rsync command. This will copy over all of our illustrations onto our frame. Then we'll run another rsync command to sync the front end, then SSH back into the Inky frame, and kick the frame service to force a refresh. And now that we've rebuilt the JavaScript, the images should be live on the frame. Amazing. So now that everything is installed on the software side, we'll actually go ahead and unplug the Pi for a moment. That That way we can get it seated on the back of the inky impression itself. We'll flip it over and orient it such that the manatee is swimming to the left here. And then we'll take the Pi with the SD card pointing to the right. And we'll align the Pi with its 2x20 header pin here and its corresponding header on the inky impression. And then press the Pi firmly into place on the board, such that the two mesh flush together. You want to be somewhat careful while doing this. The inky impression is quite fragile and thin. And so we don't want to apply too much pressure, but we want to be firm and make sure that everything is seated. And now we'll get this thing plugged in. In this orientation, the power cable goes on the far left. And upon getting this seated, you'll see a little green light turn on the Pi. While setting up my software, I ran the regular installer, which means I'll be pairing my screen here with my local Bird mic kit. But of course, as previously mentioned, the screen can also operate standalone. You'll simply pass in that bird weather flag and proceed with the software installer setup. Great, so I'm going to go ahead and get this bird mic plugged in, and then in a few minutes, we should see the e-ink populate itself with birds. I'll bring out the back frame for now. I think it's always so fun to watch these e-ink displays actually transition into their content. They're super cool. You kind of get a sense by watching them for how the Spectra tech works. I know we saw the graphic earlier in the video, but it's something else seeing the display actually go through all the pigments itself, surface the pigments that it wants to remain on the top, and you can see this bird start to appear in this like weird inverted color sense. And boom! Now we have our birds on display. Aren't they just awesome? These 6 here are populating from my local BirdNet site, which is pulling from a microphone outside of my own apartment window. And with those populated, we'll move on to mounting this display into the frame itself. So we'll go ahead and get this unplugged and set the cord aside for now. And now we have 2 separate parts here. If you've ordered a kit from me, it will come with this A4 oak wood frame. So here we have the frame you'll receive. And then additionally, we have this 3D printed backing. Again, if you've gotten this in a kit from me, it comes with this nice 3M adhesive strip already around the edge for you to fix the backing to the frame itself. But if you're printing one of your own, you can just use a bit of hot glue or double-sided tape. And the frame backing comes in 2 separate pieces such that it can fit on any standard P1S, P2S, Prusa, and then snap together nicely. And if you want to print one of these for yourself, like all the other files, you can find them on theodore.net and linked in the description below. So we'll start by removing this A4 liner sheet for now. And then we'll get the impression slotted in the frame itself. It fits perfectly. We'll go ahead and get the cable lined up and plugged back in to the left side of the Pi. And now we'll worry about orienting the cable out of this frame backing itself. You'll see in this orientation, in the bottom left, there's a little slot here for the cable to pass through. It should be the perfect size. And what we're going to want to do is hold the cable in the bottom left of the frame, and then press fit the cable between the backing and the frame itself. So this is the step where you would remove the 3M adhesive tape if you are permanently assembling this. For the sake of the video, and because I want to use this backing again, I'm going to keep it on. But you'll remove the tape here, then slide this cable over to the left, hold it in place, and starting from that edge, slowly press the backing onto the frame itself. The backing will pressure hold the e-ink display to the front of the frame, and the double-sided tape will hold everything in place. And there you have it, your own Avian Visitors e-ink display. And that's it for this video. Thanks for watching. Be sure you check out the project article on theodore.net/project/Avian Visitors. I promise it's a fun, interesting read. It goes a bit more in depth to some of the stuff behind the scenes here. Thanks for watching.